Tutorial page. They worked for me because they were actually linking to the last year's website. So it looked like it was fine to me, but obviously not to anyone else who's not enrolled. So. $5094. Okay, let's get underway. Okay, welcome to week 2, 2 of 12. Just a quick little bit of administration. For those of you who had the tutorial tomorrow at 10 o'clock, hopefully you've received an email already by now to let you know, but the tutorial, we had to move it to 4 o'clock today. So hopefully that didn't cause too much of a problem for most of you. But we couldn't find a tutor who was available to do the 10 o'clock session. So lack of teaching staff meant, unfortunately, we've had to move it to 4 o'clock. But the upside for you guys who are in that 4 o'clock tutorial is that you get Steve Remington as your tutor, which is quite good. Steve's quite fun to listen to and work with. So is there anyone who's in that tute who can't make the 4 o'clock Monday tutorial? Okay, good. That's excellent. That all works out then.
Do you record your tutorial?
Didn't for this week, for last week, because there's not really much to record. So
Previous years I couldn't find.
yeah, that's right. Because mostly it's sitting down and doing work rather than discussion. But we'll have a think about it. Particularly Steve's tute, there's a lot of discussion that goes on that might be worthwhile recording. So I might have a chat with Steve and see if he's happy to do an audio recording maybe of the podcast. But we'll have a chat. Okay, so this week we're building on what we covered last week, obviously. And last week, hopefully I've convinced you that data warehousing's quite different to the more traditional kinds of OLTP-style databases. Can anyone remember why, or some of the reasons why that might be the case? There's a couple. Does everyone remember what I mean by an OLTP database versus a data warehouse? Transactions? Yeah, exactly. So what's different from a design perspective between a transaction processing database versus a data warehouse that's designed to provide the data infrastructure for decision support?
Well, the transaction database is designed to compare the speed of the individual transactions.
Yep. Yeah.
It needs to be normalised.
that's normalisation is the term I'm looking for. We want relatively fast transactions on the data warehouse as well. We want the data warehouse to perform well, but the nature of the transactions is quite different. So because the data is normalised with a transaction processing system, that means the data tends to be split across multiple tables. So the SQL tends to consist of lots of joins, which can slow things down. The transactions also tend to, for a transaction processing system, tend to be quite small, as you said, versus with a data warehouse, they tend to be quite large. So small, frequent transactions on a transaction processing system versus large, infrequent transactions on a data warehouse. Does anyone remember the Inmon and Hackathorn definition, those key terms that describe really the nature of the difference between, beyond just normalisation, but the nature of the difference between transaction processing versus data warehousing? There were 4 terms, if you recall. Time variant is one of them, yep. Non-volatile, time variant, subject-oriented, last one. Integrated, exactly right. So subject-oriented and integrated go together. They have to do with the fact that data is coming in from multiple sources. You're trying to provide a business-oriented, business subject-oriented view of the data rather than a normalised view of the data, integrated from across multiple source systems and, as a result of the normalisation process, possibly multiple tables as well. So very often we've got a denormalised but integrated view of the data in a data warehouse. Non-volatile and time variant have to do with the idea of being able to look at data over an historical time period, so being able to track trends over time, to look at how things have changed in the past. And a data warehouse kind of represents a series of snapshots over time of transaction data, whereas a transaction processing system is very much about what's the current situation, what's correct now, rather than what has been correct over in the past. Okay, what's the one last key distinction, and this is the key difference that we're going to focus on in this lecture, the idea of the development process being different. Does anyone remember how developing a data warehouse needs to be different compared to more traditional kinds of information systems? Yes. Perhaps reflective, you'd kind of hope that traditional development's reflective as well. But I think iterative is definitely the word. Evolutionary is the other word we're looking for. So yeah, the linear style of the waterfall model approach to developing systems just doesn't work for these kinds of systems. Does anyone remember why?
Because uses for the system pop out as single list of more information for the users, etc.
Yep, that's right. So it comes back to what I've said as the reading for this week, the Keene reading, the theory of Peter Keene describing the environment in which decision support systems get developed. And whilst he wasn't talking about data warehouses, what he did talk about was relevant to any kind of system that provides support to strategic and tactical decision makers in an organisation. And that is certainly what a data warehouse does. And he argued that the only way you can actually get support out of IT for decision making is if that technology evolves to match the changing, evolving understanding of the decision problem that the decision maker has. So decision making at senior management levels or even middle level management tends not to be static, tends to be quite dynamic. Often there's high levels of ambiguity, and the fact that a system is needed to support the decision making process usually reflects the fact that the decision has lots of unknown quantities to it. So as the user uses the system and learns about the problem, their information requirements change, and that feeds on itself and becomes an evolutionary cyclical development process. So that's the same here with data warehousing. So we're actually going to focus or use that idea as the basis for an argument that we shouldn't so much view a data warehouse as a technology artifact, and I sort of hinted at this last week. A lot of the technology with data warehousing is not fundamentally different to the kinds of technology we use for other kinds of database systems development. So the kind of argument that sometimes appears in industry that a data warehouse is really just a big database, from a technical perspective, you could actually mount a fairly reasonable argument that that's the case. But really, the key difference is how that technology is used, how it's deployed. The design perspective is fundamentally different. So by viewing a data warehouse as a process of moving information from source systems to decision makers who need it to make better decisions in an organisation is actually a better way of understanding the differences and the potential pitfalls, the things to avoid, and therefore the lessons for developing more successful systems comes from viewing a data warehouse as a part of a process rather than a thing. So data warehousing rather than a data warehouse. So, any questions so far? That's kind of up until end of last week kind of stuff. Okay, let's click on. So this week we're going to look at this idea of data warehousing as a dynamic evolutionary process. We're going to look at a couple of sample alternatives to the systems development lifecycle. Just very quick snippets to give you an idea for what industry practitioners and vendors are recommending to their clients in terms of how to manage this dynamic process. We're actually going to look at these models in a lot more detail further down the semester. So this is really just a taster, a snippet to support that argument that the vendors agree, the practitioners agree, and whilst I can often be quite critical of what the vendors say, I think they're spot on the money with their approach to the systems development lifecycle. So we'll have a look at some of those, and then we'll have a look at a research project here that was actually a failed attempt to come up with an independent, objective systems development lifecycle for data warehousing here at Monash. Now, whilst that project didn't succeed, it did produce a model that provides some insight into the data warehousing process and provides a bit of an architecture or framework for understanding data warehousing as a whole. So it's worth going through and looking at that model. We'll use it as a framework for understanding the different bits of the semester as we go ahead. But like I said, it was a failed research project, so they don't always turn out. That's the nature of research. You don't know necessarily where it's going. Okay, so as I said, this idea of data warehousing as a process is founded on that stuff that we talked about last week, particularly from Peter Keane, that talks about the usage of a data warehouse as being evolutionary, and therefore the development process needs to be evolutionary as well. It's also an idea that comes from particularly Ralph Kimball's approach to data warehousing. Remember I talked last week about how there were kind of two camps in the data warehousing industry up until a few years ago, where everyone just went, oh, I'm sick of arguing and we'll just agree to disagree. But there was kind of the Kimball-ites and the Inmanites. One group following the writings of Bill Inman, the other group following sort of the approach of Ralph Kimball. Ralph Kimball's a big advocate of designing multi-dimensional data models, which we're going to look at starting next week. And Bill Inman was more a traditionalist, actually advocates for building data warehouses based on a standard third normal form entity relationship type approach. Anyway, the two camps disagreed. Where they didn't really disagree, but Kimball perhaps put it most forcefully, is this idea that data warehousing really is a process of moving data around. It's not just this technical artifact, it's a process by which data is sourced, checked, cleansed, manipulated, transformed, and then passed off to users for decision-making purposes. He actually argued that it's kind of like a publishing process. So you kind of source the data, just like an author sources material for a book, and then the data is transformed and manipulated in the same way that the author writes the book and compiles and structures a book. It then goes off to an editing process, and Kimball talks about how it's quite important not just to put data into the data warehouse, but to actually check that the data's correct. So often it's a good idea to employ someone who's a data quality auditor, or someone whose job it is specifically to check the quality of the data in the data warehouse after each execution of the ETL process. Does everyone remember what ETL means? Exactly right. Ah, you're all really good. Okay, so once the ETL process is run, you don't just assume the data's correct. Someone has to look through the data, at least check to make sure that it kind of looks right. You can't go through with a fine-tooth comb over every single data item and ensure it's correct, but you can at least look in the tables, and for example, if you think you've got maybe 50,000 customers, if you look in a customer table and there's only 1,000 rows, then something probably has gone wrong. So it's that kind of ballpark kind of thing. And Kimball argues that's really the same kind of job that an editor does with a book. So just as writing a book involves collecting data, massaging it into an appropriate format, editing it, making sure it's of good quality, and then passing it on to for sale to people to read. Same thing with the data warehouse. Source the data, transform it, load it into the warehouse, check to make sure that it's of good quality, and then finally sort of release it for publication, release it for end users to actually start using in a decision-making process. As you can imagine, it can be a real problem if decision makers are using poor quality data to make big, important business decisions upon. It can cost lots and lots of money. Okay, so what I'm trying to do is craft this argument that data warehousing really should be considered a process, not a thing. And it's really when you look at it as a process that you see the differences between data warehousing and other kinds of use of data infrastructure in an organisation. So a data warehouse itself as a technical artefact is really just one component in an overall process. But it's a component that's sensitive to changes at either end of the process. So if you make a modification to a source system somewhere, then the data warehouse has to update. And likewise, remember the delivery systems, the front end, the tools that the end users actually interact with. If there's any changes in those tools, then again the data warehouse has to change. So the data warehouse is quite sensitive because it's kind of the meat in the sandwich. It's the bit in the middle that's sensitive to changes anywhere along that supply chain of information. Okay, just to remind you about evolution, as Michael described a second ago, this is Peter Keen's kind of idea. Remember this has got to be drilled into your skulls. This is something that you'll dream about by the end of week 12. This really does describe the dynamic, almost chaotic nature of developing business intelligence, decision support and data warehousing type systems. So any systems development methodology or any project management approach to developing data warehouses needs to take this into account. If it doesn't handle this kind of dynamic process, and the waterfall model of the SDLC really doesn't, then it's going to be a problem. So let's have a quick look at a couple of example methodologies from a few different vendors. The first one we're going to look at is from NCR, which is a large company. You may have seen their logo on lots of automatic teller machines and cash registers, things like that. NCR stands for National Cash Register, and they're kind of the IBM of the retail data processing world. So NCR started out manufacturing cash registers in the 1930s or whatever, and obviously they're selling those to customers, and their customers are retail stores. One of the things that retail stores want to be able to do is analyse the data that's collected by the cash register. So NCR very early on moved into the idea of data processing, analysing retail data, and really developed the forerunner of what we would now call a data warehouse, or perhaps an ERP system. They kind of designed a hybrid kind of thing. So NCR have been doing data warehousing for a long, long time. They actually spun off a company called Teradata. So some of you will have heard of Teradata. I think I probably linked to it in the tutorial last week. Teradata are a really very well-known company specialising in data warehouse appliances. So they have their own database management system. I'm not sure whether they have their own operating system, but they certainly have their own hardware and database management system. And if you want to buy a data warehouse, if you want to build a data warehouse, you can go along to Teradata and they'll sell you a data warehouse appliance in the same way that Kmart will sell you a toaster. You buy one of these boxes, you plug it in, they'll tweak it a little bit, load your data in, and it kind of, lots of automatic tweaks happen inside the box itself based on usage patterns and the nature of the data and so on. If you want to double the capacity of your data warehouse, you go along to them and you buy another toaster, plug it in, and they start talking to each other and you've doubled your capacity. So Teradata were developed by NCR to specialise in data warehousing, and they've since been spun off. They're now a separate company. But the sort of legacy of how to approach data warehouse design and how to build these systems comes from NCR and NCR's methodology. So we'll have a look at that in a second. The second one we're going to look at is SAS. SAS started out as a statistics analysis package. I think that's what SAS stands for. They're the largest privately held company, IT company in the world, I think. That was correct as of a year or two ago. Largest privately held IT company. So they're not listed on the stock market, but of companies that don't publicly trade their stocks, SAS is the largest IT company. So they're big, they've got a presence all around the world, they've got offices here in Australia, for example. They have a very academic kind of feel to it. They were started by an academic, I think it was a mathematician who started it up. He still runs the company, I think. I did hear a rumour that he stepped down last year. Anyway, for a long time, run by the founder, so for 30 years or so, refer to each of their sort of physical locations as campuses, so that they've got that kind of real university feel to it. But obviously, what a lot of businesses are using statistics for is to analyse business problems and support decision making. So they very early on moved into business intelligence and decision support. They're focused more on the delivery system end, but to facilitate the delivery system, very often they had to develop a data warehouse as well. So we'll have a look at their methodology. I reckon their methodology is really quite neat in how it takes into account the evolutionary process and actually makes it work for them rather than treating it as a problem, which is kind of what NCR do.
Can I just add
Yep.
that ANZ uses SAS?
Lots of companies do. I reckon you'll find that ANZ also use Teradata.
Yeah.
I think Teradata in every single, each of the big 4 banks, I think. Teradata have also got a lot of large federal government departments and things like that. If you're going to work in the industry, you'll come across a Teradata installation at some stage. Teradata don't have lots of clients, but they tend to capture most of the big players in each sort of industry. So they've got, I think, 3 of the major telcos, they've got the 4 major banks, a couple of the big federal government departments. So they certainly have a big presence here in Australia. And finally, we're going to look at Microsoft, which a lot of IT people tend to look down their nose at Microsoft's methodology. And you know, I tend to be one of them too. I'm a bit of an Apple fanboy, so there's a natural tendency to criticise Microsoft. But their stuff on business intelligence, and I reckon their SQL Server stuff is just, it's really good. So I'm actually quite a fan. Anyway, let's have a look at a couple of these. So the first one is NCR's methodology. Now this looks spectacular. I've added a bit of colour to try and make a bit of sense of it. Originally it was just a black and white diagram, and it was just incomprehensible. And I reckon it still is fairly incomprehensible. NCR's started doing data warehousing type stuff in the 1960s and 70s, and their kind of approach tends to be very engineering oriented. It's a very traditional, old school IT approach to managing a project. The important thing is not so much to look at the detail there, but to recognise that there's a couple of sort of key processes going on. So what we've got down the bottom are those 3 key phases, and the colours map onto the actual specific tasks in the methodology that do that. And the idea is to highlight the fact that the edge of my slide is slightly cut off, but you can see there's a feedback loop there. So even though NCR is a very traditional IT company, they're as likely as anyone to be following the traditional waterfall methodology, which is the orthodox approach to developing systems. It's not necessarily the most common or the most successful approach, but it's certainly the orthodox approach. And you can see that, yes, there is iteration going on there. So even NCR recognises that a linear kind of process just doesn't work. So their approach really is to break up evolution into treat each cycle as a kind of linear process, kind of a mini waterfall model, but plan for the fact that we have to feed back into another evolutionary cycle to handle changed requirements. So they start out with planning, moving into design and implementation, and then, quite importantly, usage, support and enhancement. So looking at how the system is being used, how the users are interacting with the system to see where they're having difficulties or where their requirements are changing. And then those changed requirements, those enhancements, those new needs, new information needs, feed back into a planning process again, and another cycle kicks off. So their approach to managing the complexity, that dynamic process, is to treat each cycle as a linear sort of mini waterfall model, but keeping in mind that there's a whole lot of stuff that has to feed back into another cycle. Yep.
So in this diagram, there's no revolution between the design stage and the user stage, right?
Well, the idea is you design and implement. Obviously there's testing and things like that going on.
Back to the office level.
At the end of the day, you have a data warehouse audit, and then go back to consulting.
That's right. Well, so that maps onto the 3 boxes down the bottom. But the idea with these red boxes is that you're monitoring and reflecting on how the system's being used. And that includes an audit of the data warehouse itself, planning capacity, capacity planning, tuning the data warehouse, making tweaks. So there's a whole lot of stuff that you can do to perhaps improve the data warehouse without kicking off an entire new evolutionary cycle. So you might make some fine-tune adjustments to the data model, you might change some parameters of the database management system to improve performance and things like that. But at some stage you're going to get to the point where the information requirements have changed so much that you need to then really go back and kickstart another evolutionary process.
It's like a real maturity model. You get to a certain level, then high quality models come, and then
Yeah, that's right. So you kind of have two levels of evolution going on. There's tiny, small, what you'll learn about, I think, in 5094, but if not in 5094, when you do 5093, there's low-level sort of functional evolution that changes perhaps in the delivery system, maybe the layout of screens and things like that. And then there's a higher level application evolution where we're fundamentally changing what the system does, changing the application of the system. So those small sort of functional evolution things you can perhaps handle in those red boxes and the yellow boxes, and there is a bit of going back and forth between those two. But the main large-scale evolutionary cycles really fundamentally change the nature of the system. And that's where you need to really go back and do some fundamental consulting and planning. Okay, so that's NCR's approach. I think it's, like I said, there's a bit of complexity even hidden within that they haven't really drawn out. But each of those boxes are things that they can time box quite nicely. So they can say, okay, we're going to spend X amount of time doing this. Developing the data warehouse data transformation, in other words, designing the ETL process. Physical database design is going to take us this long to do. So they manage the complexity by breaking the complex process down, but also building in capacity for planning the next lot of evolutionary cycles. Okay, the next one is SAS's methodology, and like I said, this is they've actually made the evolutionary process work for them. They've built it into their business model. The way SAS sell their consulting services, so that they sell their software and then they also sell consultants who implement their software, is to sell the consulting services based on a 90-day engagement, so roughly 3 months. And what they do is they go into an organisation and the organisation says, oh, you know, we'd like to improve our decision making, we'd like to do a bit of business intelligence. So they go in and design the delivery system, design the data warehouse, and they treat that initial cycle as a fairly linear waterfall model type approach. So you can see that across the top. Assess the situation, gather the requirements, design a solution, construct, final testing, and then deploy the solution. That's fairly waterfall model-ish. In reality, what really happens when SAS go in is that they do a lot of prototyping, so lots and lots of rapid prototyping. It looks very rational and linear up there, but really what they're doing is baling wire and duct tape type stuff. And they can do that because their consultants know their software. It's their software that they're deploying. So they really know the nuts and bolts, the capabilities of the software beyond what other consultants might know. So they'll do some really interesting things with the software and sort of dazzle the client. Well, that's what I guess they're aiming to do, but deliver real value, of course. So those first kind of 1, 2, 3, 4, 5 boxes, really you'd replace with a little cloud that says stuff happens here. They do whatever they can, but they have a very definite cut-off point where they say, right, 60 days, bang, done, let's stop prototyping. What we've got now will turn into a proper system. So they document it, they rewrite the code so that it's well structured, put in comments and all that kind of thing, and then test and deploy. So their 90-day engagement is broken up into 60 days of rapid prototyping, followed by 30 days of consolidation and tidying everything up, replacing the baling wire and duct tape with a well-engineered system. But they know that things are going to change. So they'll do rapid prototyping and use the prototype to gather requirements and sort of this rapid evolutionary process through the prototyping. Then consolidation in the last 30 days, and then a project review happens, which is good consulting practice anyway. But the project review is to sit down and look at, well, where should the next cycle of evolution take us? What's the next direction? Perhaps we expand the initial pilot project to another functional area of the business. And the idea is then to sell another 90-day engagement. So they've incorporated the evolutionary development cycles into their business model to hopefully drive subsequent consulting engagements, which I reckon is really quite clever. Does that kind of make sense to you guys? So the review process is important to do, but they treat it as a chance to bid for the next potential consulting job, which is the next evolutionary cycle. You'd be surprised. But like I said, they really know their tool inside and out because it's their tool. They've designed it. They can call up the developer who wrote the particular algorithm, the code of a particular function, and say, you know, what can we do here? So they can do things with their tool that are undocumented, and you know, they can do some quite fancy stuff.
Apparently, the students can download the software.
SAS?
Yes, SAS
Okay.
software, but we need approval from you.
Okay. Well, if anyone's really keen, I suppose I'd have to check to see whether Monash has to pay a license fee or not.
They already have a license till November.
Yeah, but there might be a limitation on.
But
But we'll see. Yeah. Certainly, if you want to play around with it and it's free, I'm more than happy to tick a box. Okay, so the last one is Microsoft's methodology, and this comes from their second edition of a book that they wrote on data warehousing. Their first book came out roughly when they acquired SQL Server. So SQL Server 2000 was 1999. They published a book on data warehousing. Microsoft recognised in the late 1980s that business intelligence and data warehousing was a real growth area for organisational computing, and they were wanting to move away from just desktop computing more into the back end, the back office type stuff like data warehousing. So SQL Server was part of that strategy to move into business intelligence and data warehousing. They got some good data warehouse consultants to write a book. Unfortunately, their first book was, yeah, I wouldn't recommend reading it. It's good for a bit of a chuckle, and I've got some interesting quotes later on that I use that show some misconceptions they have about the industry. But their second book was actually really good, and it included this methodology. And I reckon this is actually a really good methodology. Well, I shouldn't say despite it being Microsoft, but despite what some people would think about Microsoft, this is actually a really good, well-focused methodology for, I guess, what you'd call small to mid-scale data warehouses, what we call data marts, even though they'd argue that this ramps up to large-scale data warehouses as well. So their approach is to have this central, fairly linear kind of process, again, kind of that first iteration of the evolutionary cycle, gather the requirements, and analyse and design it, build it, document it, test it, install it, and give it off to usage, to end users to actually use. But key to their methodology is a recognition of two major influences on that drive evolution. One is the user experience, and that's what Peter Keane was talking about. So this is the classic dynamic process that I had as slide number 3 here. As the users use the system, their requirements change and so on. So they end up with user enhancement requests, bug reports, those kinds of things. And that drives evolution as well. But importantly, they recognise that there's another key driver for evolution as well, and they tend to be technical requirements. So as the technical team maintain the system, keep it running, they notice that there's improvements that can be made, perhaps a new version of the DBMS comes out, or maybe they recognise that there needs to be a change to the data model, or maybe some of the queries can be fine-tuned so that they run faster. So you end up with, gets me every time. I really should back my computer up. 11 days since I've backed my computer up. Okay, so we're back. When I get back to my office, I'll back up my computer. So, like I said, two key influences on the drive evolutionary changes, the user stuff that Peter Keane talked about, and more technical, maintenance-oriented driven change. And both of those can feed back into new requirements and kick off another evolutionary cycle. So Microsoft's methodology is really good because it recognises those two key factors as quite explicitly, which some other methodologies don't pay that explicit attention to those two key drivers. So managing those changes those pressures for change means that you're more likely to have a successful system down the track. I was going to say at the end, but there really is no end with an evolutionary development process. You just keep going until you decide, okay, we're done with this, we'll move on to the next kind of data warehouse approach. Okay, so any questions about any of those? All right, so the key thing is managing that evolutionary process with the process models, and the traditional waterfall methodology doesn't work unless you're scoping the project so that each evolutionary cycle is itself treated as a kind of mini project. And that's a relatively sensible way of tackling project management with data warehousing. Break down the complexity, the dynamic process into more manageable, more traditional kinds of projects. Choose a pilot project at the start that's going to deliver some quick wins, so something that's easy to develop, something that's going to be of value demonstrable value to the business, so business users start getting value from it very early on, and that's going to drive not only requirements gathering for the next iteration, but it also means that the organisation is going to be more willing to spend money on the next iteration as well. And one of the key problems with selling an evolutionary project is that you don't have a deadline and you don't have a definite budget because you don't know what the system's going to do down the track. But if you treat each evolutionary cycle as a project, then it becomes easier to sell to the business. The consequence of that is that you tend to find data warehouses treated as a series of projects rather than infrastructure of the organisation, and that becomes a problem with ongoing recurrent funding. You're not sure next evolutionary cycle whether we're still going to be around or not. So there is some good evidence that we've collected here at Monash, particularly David Arnott's done some really good research looking at a couple of failed data warehousing projects actually, that argues that really data warehouses shouldn't be funded on a project by project basis, but treated as infrastructure. So it has recurrent funding every year. But of course, convincing the business to do that can be really quite a challenge. Okay, so that brings us kind of to the halfway point. I was going to waffle on a little bit more about methodologies, but I won't do that. It's kind of the point where I'd take a break, but I think it's a little bit early to do that, so we'll push on. So there's a number of different methodologies out in the marketplace, but there's very little research done in academia on data warehousing. Disturbingly small amount of research. It's a major part of the IT industry. Gartner put BI, business intelligence and data warehousing, as their number 1 or number 2 CIO priority for the last, I think it goes back to the last 7 or 8 years of their Gartner survey. Recently that's dropped down a bit, but it's still at number 5 out of the top 10. So out of all the priorities that CIOs have in organisations, BI and data warehousing is one of the key priorities. Data warehousing is fundamentally different to other kinds of technology in terms of requirements and management, but there's very little work done from academics to actually look at best practice and distill the lessons that we can give to industry to help them do the job better. So as a result, most of the material that's out there comes from vendors and consultants and practitioners. There's very little in the way of sort of objective analysis of project management approaches and those kinds of things. And as a result, most of the methodologies tend to reflect the business models that those organisations have. So if we look at NCR's approach, this reflects the fact that they're an old school retail data processing kind of engineering style organisation. If we look at SAS, their business model is based on the 90-day engagement, and their methodology reflects that. If we look at Microsoft, this is a methodology aimed at mid to small scale data warehouses, data marts, that work very well with their SQL Server database management system. So the methodology is kind of driven by the technology offerings that Microsoft have. So each of the methodologies are quite different, but they tend to reflect the business structure, the business model, the services and products sold by the companies that publish them, which is not particularly surprising. The downside, of course, is that there's a hidden agenda with these models. They're there to sell business, sell books, sell consulting services, sell software. There's very little in the way of objective, independent research done into methodologies for data warehousing. In fact, there's very little research done into data warehousing full stop. Okay, so that was the kind of impetus for us here at Monash to launch into this research project. We've done a couple of projects on methodologies for other kinds of business intelligence systems. So we've got a Monash method for decision support systems development, which you'll learn about in 5094. We've got a methodology for what we call executive information systems development, the Monash EIS method, which is really business intelligence methods. So a methodology to develop the delivery systems as part of the BI project, part of the BI stack, but nothing for the data warehousing sort of layer. So that's what we set out to do, and as I said, it turned out to be a bit of a failure. It wasn't as successful as our DSS or EIS methods, but it's still worth looking at. And as I said, that's the nature of research. You don't necessarily know where it's going to head. So I'm going to talk to you about the journey, because research is it's not the destination, it's the journey that's important, and walk you through the different iterations of the model that we came up with. And it will give you a bit of insight into, A, what the literature says about data warehousing, which is actually not a lot, and B, some of the concerns that industry have about how to tackle data warehousing. So we started out saying, look, we're a research group here focused on decision support systems and business intelligence, successful methods for DSS development and EIS. So we thought, well, we need to focus on data warehousing. Here at Monash, before my time, of course, we were very sceptical. I say we. The research group was very sceptical about data warehousing. One of the big problems with decision support systems in the early days, when they were first developed, it was around the 1960s and 1970s that DSS first became a recognised kind of IT application, was that the focus was on developing what were known as management information systems, which were large-scale repositories of data. They produced, really big, thick, static-type reports that ended up on managers' desks, and they were a complete disaster. How many people not doing 5094? Everyone's doing 5094? So you've all heard David talk last week about management information systems and the failure of MIS systems. Can you recognise the similarities in the descriptions of management information systems and the nature of data warehouses? MIS, large collections of data, the idea or the main motivation being to process data and simply make it available to managers, and if you make it available, then this kind of utopian world of informed decision making will naturally bubble up. It just doesn't happen. It's kind of the same thinking that drove the development of data warehouses, particularly in the 1990s. This idea of, let's build a data warehouse, we'll collect all the information in one place, we'll make it available to people, and that's going to, in and of itself, improve decision making in organisations. Didn't happen for MIS, and we reckoned it wouldn't happen for data warehousing either. And we were actually kind of right. In the 1990s, there were lots and lots of failed data warehousing projects, and we attribute most of that failure to that mindset of, let's build the data warehouse and that's kind of it. The data warehousing projects that really work well are those that focus not just on the data warehouse, but also the delivery system. So paying attention to actual decision support, the tools that the end users use to improve their decision making. So to a certain extent, data warehousing is kind of a secondary concern. But in the 1990s, it was the main focus. Lots and lots of money was spent on building very large, very complex data warehouses, and they failed in many cases. However, the industry learnt a bit. They were a bit more successful than the old MIS systems, and they really did become a key part of the IT industry, particularly business intelligence part of the IT industry. So we couldn't ignore it as a research group. Industry was launching down this track of developing data warehouses, and we have an ethical and moral obligation as academic researchers to try to improve. It is the wind. Must be a pressure lock or something. So to improve IT practice in this kind of area. So we decided to turn our attention to it, but we did come from a DSS perspective rather than a database management system perspective, which is a key distinction. So we're very much focused on data warehousing as a process, as a design kind of process. Sorry, just bear with me. I think a door needs to be opened. Give me 1 sec. All right, I'm back. Okay, there's going to be sound of bins moving and banging around on the podcast. My slides have moved forward. As I'm moving bins, I'm pressing buttons on my phone. So where we're coming from is DSS perspective, systems analysis and design perspective, treating a data warehouse not so much as a technical thing, but as a process. So focusing on development. And also regarding data warehousing, not as a thing in and of itself, but as infrastructure for decision support, business intelligence, executive information systems, and so on. Now, there was little research at that time. There's still very little research at the moment as well. So it's still an open research problem. So this was I say our, it was actually before I joined Monash. So when I say our, it's not me personally, our research group. This was our kind of approach. And this is a classic research method approach. It's kind of the basic process that any research project will go through. The first thing to do is to look at the literature and see, well, what have other people said about the problem? What can we learn from the literature, particularly the academic literature, but also looking at industry literature as well, and trying to integrate that, distill the key lessons and come up with what we thought was an initial reasonable kind of model that captured those issues, and said, okay, well, here's the kind of rough process that you go through. Sorry, I've lost connection. Okay, so coming up with that initial preliminary process model. The next step was to take that sort of lessons from literature and present it to a number of industry practitioners, experts, people who've gone out and developed some successful data warehouses, people who've gone and developed some unsuccessful data warehouses and drawing on the lessons that they've learnt from there. And then refine that initial model and come up with a sort of a revised process model. And the idea was that we could take the best of the lessons from academia, kind of the ivory tower perspective, but also ground it in actual practice, so that we've got the viewpoints of both. One of the problems with taking lessons just from practice is that it tends to be quite blinkered. It's very hard to get that high-level overview when you're in the trenches working away at trying to develop a data warehouse yourself. But likewise, if you just focus on the academic research, it can be a little bit too removed from practice, and so you lose that kind of practical, pragmatic kind of input. So we're trying to capture both there. An initial model based on the literature, and then refine that based on discussion with actual practitioners. And then the idea was to then take that revised model and look at a number of case studies that have been done, that had appeared in the literature, that we'd collected data from and that other people had done, to see whether what happened in the literature was predicted by the model that we came up with. So in other words, would the model predict successful case studies, highlight the reasons for success, and also predict failed case studies and highlight the reasons for failure there. So if we found that there was a good match between what happened in the case studies and what the model said, then we could be fairly confident that the model was fairly good, was high quality. We also wanted to run a couple of focus groups, again, bring practitioners in and in a really intensive closed room kind of session, thrash out some details of the model and see what we could come up with to produce what we hoped would be a really good systems development methodology for data warehouse practice. So that's kind of what we were hoping to do. And we got most of the way through. Well, we actually got all the way through, but we got successfully most of the way through. This was our initial process model based on the literature. So we identified a number of literature sources that talked about organisational factors influencing data warehouse success. There's a design process, and one of the key things that comes out of particularly the decision support literature and the executive information systems literature, the BI literature, is that having strong management support is really key. If you don't have management support, if it's driven just by the IT department, then chances are you're going to have a failed data warehousing project or BI project. So the idea is that those three initial things feed into the design of the data warehouse and the delivery system, and that then influences the outcomes of the use of the system. So user satisfaction and other kind of development outcomes. So kind of reflective of the issues that the Microsoft methodology had. But this was our initial pass at looking at a method or a model that explains the data warehouse development process. Now, it's a long way from an actual systems development methodology. It's really a factor model. It says, here's a number of factors and here's the influences between those factors that lead ultimately to either a successful outcome or a failed outcome. But this was our starting point. So it highlighted issues. We could then use that to refine this really factor model into what turned into an initial process model. So key in the literature was this idea of getting management support, understanding the initial set of requirements, getting the project together, selling the organisation on the project and getting commitment to the project. So there's a lot of discussion in the literature about the initiation of the project. It's a key phase in the data warehousing project. So we said, right, we need to explicitly recognise initiation as part of the process model. Then there's development, and we didn't break it down any further than that. We thought we'd leave that to down the track a bit. But there's a development process, and then the system gets used and the delivery system gets developed and used, and there's an interaction there between usage of those two systems and a driving change in requirements. So you can see that there's two-way interactions between those things, kind of similar to Keen's model. As the warehouse is used, that drives changes in requirements which change the warehouse. As the delivery system is used, it changes requirements which drive evolutionary changes in the delivery system. And changes here, of course, feed back into changes here as well. So there's evolution going on with those two-way relationships. So this is the model at the point before we start talking to practitioners, to do some case studies, to do those focus groups. And whilst it's very, very high level, we think that it captures a number of the key, we thought that it captured a number of the key issues. So that key issue of getting the project set up properly, sold to the business agreeing to this kind of evolutionary process rather than the more traditional waterfall approach of deliverables and milestones and budgets that relate to that. And we can drill down into those bubbles in a bit more detail down the track. So this was our initial model. As I said, initiation was about setting the project up, getting buy-in from the organisation, working out what the purpose of the data warehouse and delivery system was all about, and getting that project champion, that project sponsor online and actively advocating. And working out whether the project is being driven by the IT department or whether it's being driven by the business side, or perhaps the third alternative, it's actually being driven by an external consultant who's coming and said, right, you need a data warehouse. In most of the case studies of successful projects that we've seen, it's often driven by the marketing or finance departments, just because there's a natural need in those two areas of the business to get good quality data from right across the organisation so that they can make, in the case of marketing decisions, marketing campaigns and so on, in the case of finance, to better understand how cash is flowing through the organisation and how that can be managed better. So successful projects generally are driven by the business side. There have been some successful projects driven from the IT side, but it's a riskier proposition. And likewise, consultant. The disadvantage of a consultant-driven process is that you don't have organisational buy-in at all. It's just driven externally, and when the consultant leaves, the project just sort of withers and dies. In the development process itself, so that second bubble, the recognition was that it's very much an evolutionary development process. It's about identifying the information requirements, getting something out quickly so that the usage can start to kick in, and that then drives the requirements over time. Key to part of that is that ETL process, so sourcing the data, designing the ETL process, but also dealing with data quality problems, so cleansing the data as well as a number of technical decisions that have to be made. Delivery system development, this is the stuff you study in 5093, which is in second semester. So I won't talk too much about that, but the Keynes model is very much evident in that process. The idea of the delivery systems is typically OLAP style, drill down, drill up, slice and dice, pivot table type interaction. That's the nature of the delivery system, and it's not really the focus of the model, but it recognises that the evolutionary process tends to be much more focused on the delivery system because that's the point of contact between the users and the IT infrastructure. So the pressure for change is most directly felt at the delivery system side, and that then flows through to the data warehouse as well. The key thing that came from the use bubble, from looking at the literature and saying, okay, usage is an important thing to have in the methodology. It's not something you see in the waterfall model, for example. Is recognition that usage is an active part of the development process because of the evolutionary process. So when you've got an evolutionary development process, usage is the thing that drives the evolution. So it is a key phase, which means that you need to put in place strategies for monitoring how the system or the infrastructure is used, how that usage changes, where there's bottlenecks, where improvements can be made. And there's a number of different strategies you can have to do that. Probably the most effective is to turn on logging on the system, so keep track of actual usage, keep a log file and see how usage patterns change over time. Another way is to actually just watch people use the system. That gives you some insight into particularly the user interface design, but also areas where they're struggling to find information, so you can perhaps improve things there. The other way is to have a kind of a formal change management process, so a system to lodge change requests on the part of the users. The main thing is to have frequent open contact between the users and the developers so that a close relationship forms, so that when a changed requirement does pop up, the developers know about it very, very quickly and can see the need for it. So one of the problems with I guess the IT industry as a whole, sort of IT people, tends to be that we can be somewhat sceptical of the requests of users. Yeah, we'll get to that when there's other things that we need to prioritise over that. But when you've got a close relationship with the users, you've got perhaps a little bit more empathy, but also you directly see the need, and that tends to drive those changes up the priority list a little bit more. So key is having a close relationship between developers and users and monitoring the usage so that when a change requirement occurs, that flows through to an actual implementation change as soon as possible. One of the big things in the literature is recognition that as users use the system, not only are their requirements changing, but they're using the system in ways which we often don't anticipate. So if we don't have a close relationship, if we're not actively monitoring how the system's being used, then we don't really understand how the end users are actually using the system and therefore can't design appropriately. Okay, so we were moderately happy with that model as a process model. It's no longer just a factor model. It shows a kind of a process of development. And it's based on the literature. It was fairly rigorous. It was based on some initial discussions with practitioners as well, so we felt that it was relatively grounded in practice too, but still very high level. So the next step was to actually apply that model to a number of different case studies. So I'm going to show you how we did that with four different case studies, but I reckon we should take a break because it's 11 o'clock. So we'll take a 5-minute break, we'll come back and we'll have a look at these 4 case studies and see how the model performs in terms of predicting success or failure.
Hey Rob, how are you doing?
Good, thanks. How are you?
Good. After I sent you and David email,
Yep.
I've read the research in articles again and found a little bit tricky that my interests match with the project that you currently have.
Okay. Oh, so you mean the website?
Yeah,
You've
the
looked at the website. Yeah.
Yeah.
Okay. All right. Well, what you probably need to do then is perhaps look at some other research groups and see what they're doing that might align a little bit more with what your interests are. What sort of things are you looking to do?
It's more related to business, how to allocate jobs more efficiently and more effectively, not instead of in the perspective of IT person that develop a methodology to serve the business. I'm not really.
So a methodology to manage sort of open IT projects in an organisation, is that what you mean? Or like to prioritise IT projects in an organisation, is that what you mean by job?
Yeah, a little bit.
Okay.
So I'm not that good at IT stuff.
Yeah.
Because last year I completed the business system track, not business intelligence track.
Look, it might be worth looking at, say, project management. So having a chat with some of the people who teach the project management specialisation.
Not yet, but
yeah, what I'm saying is it might be worth doing that.
Yeah.
So there's probably two key people to talk with. Either Jose, who's one of the lecturers for the research methods class. I don't know whether you've met him yet. You're doing research methods this semester.
Yeah.
So was David teaching or was Jose teaching?
Joel is
Oh, right. Well, he also teaches the project management track. So have a chat with him, but I don't think he supervises students. The other person who teaches into that track is Henry Lee, and he does supervise research and tends to be at the softer end of project management rather than the technical end, which is where Jose is. So perhaps next time you see Jose, or perhaps organise to meet with you, so interested in sort of project management, particularly IT project management, coming up with methodologies for prioritising your project. So it's kind of a governance thing. And also perhaps have a chat with Henry as well and see if there's opportunities there. Henry is much more into knowledge management and information as part of project. So treating project management as a knowledge management problem, whereas Joe's is much more quantitative in its approach. But definitely they're the people I'd be talking to, I think, given those kind of interests. Yeah. I mean, ultimately, you've got to pick a project that is of interest to you, but someone in the school can supervise. So if there's someone who can supervise you, then that's a problem. And you'll have to refine it. Choose a topic that's a little bit different to what you're interested in. But yeah, Henry and Joe sound like they're the most likely potential supervisors. With Henry, I'd chat with Jose first. And just see what the situation is, whether he's willing to take on the students to supervise. And if not, if he's not happy to do so, perhaps ask him for an introduction to Henry. Oh, good. Well, that's the idea. If you're sitting here in a master's class and you're not being challenged a little bit, then there's something wrong there. So, yeah. Okay, no worries. Okay, let's get underway again. So what we've been looking at so far is this idea of data warehousing as a process rather than a particular piece of technology, and what turned out to be a failed research project on our part to try and come up with an independent systems development methodology for data warehousing, but wasn't trying to sell a product, but that was actually based on the idea of actually producing successful data warehousing projects down the track. So key to our methodology was the idea that the delivery system and the data warehouse have to go together. If you're doing the data warehouse by itself, independent of any kind of delivery system, without thinking about what the delivery system is going to be like, then chances are you're going to be building what we call a white elephant, a piece of infrastructure that no one's ever actually going to use. So those key components, the warehouse, the delivery system and the usage, interacting together to drive evolutionary development were the key lessons that we saw coming from the literature. Plus that initiation stage, so setting the project up properly, getting project champion support and things like that. So the idea was then to take this and look at a number of case studies and see whether it predicted the success or failure, the outcome of those case studies. So we've got four that we amongst many that we looked at. The first one was an organisation that worked in the finance industry. This was actually a Teradata project. So it was a very large, I think it was one of the banks. I can't remember whether it was an insurance company or not, but I think it might have been one of the banks. And the idea with this project was that it was a Teradata project, and the emphasis was very much on the data warehouse itself. So this is the technical architecture for the project, what they ended up producing, and it's not too different from our perception of, in our methodology of what the project, what the architecture might look like. So you've got the warehouse itself, and you've got a delivery system that end users actually interact with. But notice what the delivery system actually consists of. And as you're noticing what the delivery system consists of, SQL commands, have a think of who the users actually are. So who are the users of a data warehouse? They're BI users, senior level managers, CEOs, CFOs. They're very smart, but they're not necessarily technically competent. So the emphasis was very much on building this thing and not so much on the delivery system. So it was kicked off by the retail group, and what they were trying to do was, the classic problem with banks was consolidating accounts, working out which customers were, regarding customers as individual people, and identifying households of people as well, so they could better market and sell products to them. One of the classic problems in any kind of retail situation is where you've got customers who've got the same name, perhaps even the same address, but they're actually different people. Or the opposite problem where you've got multiple different names, different addresses, but it's actually the same person. So trying to identify who the individuals are and group them into households and better understand account holding information was a real problem. And they wanted to build a data warehouse to try and solve that problem for them. So the warehouse process consisted of developing, first of all, a corporate data model. Now, has anyone here ever worked on a corporate data modelling project? One or two? How did it go?
Corporate model for the oil fields.
Okay.
So it was kind of comprehensive for all the oil field facilities, the production data, and the testing
Yep.
models.
So were you involved in the development of the corporate data model right from the very start, or did you come in down the track?
It's evolving. It's evolving data models. New technologies appear and
Yeah.
new data requirements are needed by the engineers.
How long has the project been going on for?
I remember it was an old, let's say a crappy data model built in DB2 because this was like built by petroleum engineers, so they're not really specialized in this area.
Yep.
And then in 2000 they moved to an Oracle database where they kind of revised the whole.
Okay, so the data model's still being developed, and it was the current version kicked off in 2000, is it? So 11 years down the track. That kind of gels with my experience. Benji, you said
Evolving all the time.
yeah,
Because of users' needs.
because the business changes, it's continuously changing. And, 10, 11 years, that is actually quite a long time. I've worked on corporate data modelling projects that I thought were a long time. They're in the order of 1 or 2 years. And that was without actually implementing anything, so it was purely logical, conceptual data modelling. The classic problem with doing a corporate data model, this is the idea of mapping out all of the organisation's data assets and right down to the field level, is that there's so much of it. There's lots and lots of different systems, there's incompatibilities, there's duplication of data, there's gaps in the data. Wrapping your mind around the complexity of building a single data model for a single system is hard enough, let alone a corporate data model. They tend to be of two types, and for those of you who've done 9003, you might have heard me rant about this a little bit because I've got a personal passion of hatred for corporate data models. Basically, because I was on one of my early projects I did as a consultant was a corporate data modelling project, and I just hated it with a passion. I found out in the end that it was the state government department, wasn't Victoria, the state government department that hired myself and the company that I belonged to do the consulting job, wasn't so much interested in the corporate data model. They were more interested in spending the money so that the budget cycle could be inflated. So, nice waste of taxpayer money right there. And it produced a data model that was illegible. It was so complex, no one could understand it. Even myself and the other couple of consultants who were doing the actual modelling got to the point where we just couldn't understand it. We couldn't read it. It looked like a spaghetti diagram. After a couple of days, it looked like an electrical schematic, and it was still kind of understandable. But after about a week of modelling, not a chance. Anyway, corporate data models tend to be of two sorts. Either that really, really complex sort and take forever to develop, lots and lots of money to build, or they're very, very simplified. So they're very high level, very abstract. We've kind of got information about these topics, and these topics. Not really a data model in the ER model sense, but just a very high level overview, which from a data warehousing perspective is not particularly useful. So whilst a very detailed corporate data model can be very useful for developing a data warehouse because you want to know where the data is coming from, what format it is and so on, usually they're so complex you can't understand them, they're useless anyway. Or they're so high level that you can understand them but they don't give you much actual help in building the data warehouse itself. So this idea of doing a corporate data modelling project first, spending 11 years developing a corporate data model.
Actually, the migration was 2 years, but
What about the actual modelling process itself rather than building the database?
I think it was 2 years to basically re-engineer
Yep.
both the existing data models and
Okay, so the design process, 2 years. Can you imagine doing a 2-year corporate data modelling project before you even get to the data warehouse? And remember what I said earlier, the idea of chunking up the data warehouse, treat each evolutionary cycle as kind of a linear process, but get the pilot project, choose a pilot project that is going to deliver some quick wins. And when I say quick wins, I'm talking in the order of months. But if you're doing a corporate data model first, you spend years and a budget appropriate to years' worth of work, even before you start building the data warehouse. But anyway, this is what these guys did. Corporate data model first, and then bought Teradata sell the hardware and the DBMS, so specialised hardware and software from Teradata. There was quite a complex data sourcing structure they had to adopt. The ETL process was very complex because of the bank systems that they already had. The source systems, there was lots of them. Some of them were designed in the 1960s, some of them were designed in the 1990s. Lots of different kinds of modelling approaches and formats and things like that. They spent a lot of time getting the ETL process right. So as a result, lots and lots of delays. It was a long time before the organisation started to see the first trickle of data come out of the data warehouse. The delivery system development was an afterthought. It wasn't even an afterthought. It was just they need some way of getting access to the data warehouse. We'll give them an SQL tool. So managers were given an SQL tool. They had to bash out SQL to try and get anything other than standard reports. So remember last week I talked about standard reports versus ad hoc reports? Standard reports are the ones that you run every time on a regular basis. They don't change, you can predefine them, which is fine for operational decision making, but for strategic decision making, tactical decision making, the classic kind of decision support, business intelligence, you need ad hoc reporting, and for that they just had SQL. So the result of that was that as a result of not paying attention to the delivery system, which is a key part of our methodology, there was really poor usage of the warehouse. Very few people actually used it. And after a year or so of work, I think it was actually 18 months in developing the corporate data model and the ETL process, the project was cancelled. And we're talking millions of dollars here, just thrown away. So we reckon our methodology predicted that, because the key thing in our methodology is that you have to pay attention to the delivery system as well as the warehouse system, and you have to pay careful attention to the usage of the system so that you can adapt the overall data warehouse and the BI tools to how people are actually using it. And simply throwing an SQL tool at managers is not going to cut it. So we reckon our methodology would have predicted that this project would have failed. Okay, so the next one, this is a manufacturing industry case study. From memory, it was a cement company. So the main product they produced was cement, concrete. Bags of cement that turns into concrete. So the cement industry is actually really interesting. Did you know that from the point of manufacture of the concrete, so the cement is the powder, as soon as they mix that, put it in the big trucks and mix it, they've got 2 hours to use the product. So from the factory where the trucks get loaded up, they've got 2 hours to get on the building site and put that cement down. Otherwise it goes off. It's just incredible. So the logistics of concrete is astounding. Anyway, that's the engineer in me going, oh, that's kind of cool. Anyway, manufacturing industry case study. This is their kind of approach. Again, the technical architecture is pretty much the same as the previous one. From a technical perspective, nothing radically different. The real key difference with this one is the use of a graphical business intelligence tool. So something that's relatively intuitive, easy for end users to understand. But from a capability perspective, you could get the same data out of this graphical tool as you could from handcrafting SQL. The only difference is the user experience. In fact, the data that's being put into the data warehouse is a little bit more complex than the previous case study, because we've got not only data coming in via an ETL process with the source systems, internal source systems, but there's external data coming in as well. So that's being integrated. So arguably a lot more complex than the previous Teradata case study, this one here. Oh, hang on. Wrong side. This one here. So the manufacturing industry one was kicked off by the IT department, which we often say is not the ideal situation. If it's not championed, if it's not initiated by the business side, then that's a potential problem. But there was very early on some strong sponsorship by the CFO, the Director of Finance. There was no formal cost-benefit analysis done, which again is something we would recommend is not ideal practice. But they did have business buy-in. It was driven by the finance department, even though it was initially led by the IT department. The development of the warehouse itself was specifically designed to support the delivery system. So the key difference in mindset between this case study and the previous one is that it's the delivery system that's the main focus rather than the warehouse, which is the main focus with the previous one. So they spent a lot of time thinking about the business intelligence tool, the executive information system, and also thinking about how to integrate the internal and external data sources to bring it together in a coherent whole. The development process was evolutionary, so they recognised that there's an evolutionary process going on, and they utilised that graphical, OLAP just stands for the standard graphical business intelligence kind of environment. Usage of the system, therefore, as a result, was actually a lot higher. The system was really considered incredibly valuable. In fact, during the prototyping process, so the initial evolutionary development process, before they even really deployed the tool, just playing around with the data, getting some initial reports out of the data warehouse, they identified a real key business problem. What had happened was that a competitor had come into the market almost overnight. We're talking like in the period of a couple of weeks or so, entered the market here in Australia, and previously this company was the market leader in the industry. They had something like 80% of the market share in that particular industry, and this competitor came in and hired some of their ex-salespeople and took over a whole lot of their clients, and almost overnight their market share dropped from about 80% down to I think it was less than 50%, so down to about 40% or so. So that's a big cut in their business. But their reporting cycle, one of the reasons they were building this system was to improve the reporting cycle, so report on sales and potential sales and things like that. The reporting cycle was in the order of 8 weeks. So from when the data is first collected, the initial transaction come in, to when it actually gets reported on was in the order of 8 weeks. But because of the data warehousing project, they were starting to get much more rapid turnaround. So they were analysing data that was no more than a couple of hours old rather than a couple of weeks old. And they identified the fact that there was this really quick drop in sales in their clients. And as a result, they were able to get their sales force out and win back as many customers as they could. And they actually got their market share back to almost what they had before. And they turned it around in a couple of weeks' time. But if they'd waited that 8 weeks, they would have lost those customers permanently. So we're talking millions and millions and millions of dollars saved because of a prototype data warehouse. So, you know, they were into the project about in the order of a week. They'd been doing the project. So after a week, they were already getting benefits that paid for itself many times over. All because they were messing around with the data, but they were developing it in close consultation with the end users as well. So it was an interactive evolutionary development process. So that close relationship between the users and the developers meant that the problem was identified. So the successful outcome, we reckon our model predicts that quite nicely by placing the emphasis on paying attention to the delivery system as well. And even though from a technical perspective, almost identical apart from the nature of the delivery system tool to the failed case before. So we think our model's pretty good at this stage. The predictive power of the model is pretty strong. It's not the technology, it's the stuff described by our model. Here's another one. This is a transport industry case study, one of a big logistics firm, kind of like the Lindsay Fox transport company. I won't say it's necessarily them though. They developed a data warehouse. They used Ingres in this case. Ingres now owned by Oracle, I think. No, Ingres got open sourced, became Postgres. Anyway, Ingres was the database platform. They had a standard ETL process sourcing data from internal data sources. They also had a system administrator who was doing a bit of manual data entry as well. So someone who was focused on that kind of publishing role that Kimball talked about, the idea of looking at the data quality, supplementing the data, fixing the data up at the data warehouse layer as well. They also had a graphical BI tool that the end users used as well. This one's interesting because it was quite unorthodox in its approach in that it outsourced the development of the delivery system. Now, what the literature says in regards to outsourcing, and it's quite tempting to outsource a number of different IT functions. The literature says if you're looking for things to outsource in a business, the prime candidates for an outsourcing project are business functions that are non-critical, non-core business, and don't have any sort of strategic importance to the organisation, and that are fairly routine. You can define the service levels quite easily. You can say, this is the service we want from the outsourcing provider, and this is the level of quality that we want on an ongoing kind of basis. Business intelligence doesn't fit into that in any way whatsoever. BI supports strategic decision making, so it's strategic to the business. It's core business, it deals with core business information. The data is often internal to the organisation. And because of the evolutionary development process, you don't know exactly what you want the system to do, and you want continuous changes and updates to the system. So therefore writing a service level agreement or a contract with an outsourcing provider is really difficult to do. So the literature would say, never outsource your BI development or BI operation. But these guys did that, and it turned out it worked out kind of okay. And the reason it worked out okay was because there was a very close relationship between the CFO of the outsourcing company and the CIO of the transport company. Turns out they were both, the CIO was a former CFO himself, so accountants kind of mingle together. They go off to CFO gatherings every now and then, and they all seem to know each other. So there was literally on the golf course, they were playing around a golf together, and the CFO of the outsourcing company pitched to the CIO, and there was a kind of a gentleman's agreement about the development of the delivery system. And because of that relationship that they had, it worked. So there was a flexible contract put in place and so on. So we wouldn't recommend it by any means as the standard way to go. A classical outsourcing arrangement just wouldn't work for BI. But in this case it worked because it was an unusual outsourcing arrangement. Anyway, the warehouse was developed in support of that delivery system. So it wasn't just, let's build a warehouse. It was, we need to do business intelligence, we need an executive information system, we're going to need to source data for that, so we'll build a data warehouse to support it. So that first failed case study was very different. Usage was quite successful, and in fact there's been a number of evolutionary cycles since then, but the emphasis was placed very much on the delivery system, not the warehouse itself. So again, we reckon our model supports the success factors there. And here's another one. This is again this is a retail industry, so office equipment manufacturer. Again, technically pretty much the same. You've got a warehouse, a delivery system, graphical BI tool in this case, corporate data warehouse, corporate databases feeding in through an ETL process. And with this one, they were supplementing the data warehouse with general ledger data being fed in as well. So again, a bit more complex than that first failed case study. But the technology is pretty much the same, slightly more complex environment. But again, this one turned out to be a success because there was focus on the delivery system. The warehouse was developed in an evolutionary process. There was a monthly ETL refresh of the data warehouse, which is a little bit on the infrequent side, but not unheard of. So when we talk, I should talk a bit more about ETL processes down the track, but ETL processes are designed to run in batch mode. That is, they're not continuously running, they get run on a regular frequency. A lot of organisations will do it once a night or perhaps over the weekend. In this case it was once a month, but not unheard of. But that means that the data in the data warehouse, of course, is up to 1 month old. So you need to keep that in mind when you're thinking about designing the ETL process. There's a lot of, up until a few years ago, there was a lot of talk in industry about what was known as real-time data warehousing or right-time data warehousing. And this was the idea to try to get to this situation of continuous updating of the data warehouse. So as a transaction occurs in a source system, it flows through immediately to the data warehouse. I've never really seen it work. The level of complexity, the expense you have to go through to get that real-time data in the data warehouse is astronomical, and the payoff is actually quite small. Most strategic decision making happens isn't as sensitive to what's happened yesterday as opposed to the cumulative effect of what's been happening over the last couple of years or couple of months. So the benefit of that real-time data is actually quite low. Yeah. Yeah. So yeah, strategic, tactical decision making, it's not as sensitive to real-time data, and it's really expensive and really hard and really complex to actually implement that in a warehouse. So yeah, even though it was a selling point of organisations like Teradata and a lot of consultants, get your real-time data now, the payoff is fairly low. So monthly refresh, not unusual. It's perhaps less frequent than typical. Usually it's overnight or over the weekend. But we reckon this one, again, was predicted by our methodology. So at this stage, we've developed a methodology based on factors in the literature. We've gone and talked to industry practitioners and come up with a process model that we're fairly comfortable with, very high level, very 90,000 foot view of the process. But still, we reckon that the model is predictive enough to say, if you follow this path, you're more likely to have a successful project. If you follow this path, you're more likely to have a failed project. So at this stage, we're now ready to sit down with focus groups of experts, data warehouse practitioners and consultants, a mixture of consultants and vendors, and nut out some of the detail in the model. And we're pretty confident. We've compared it to case studies. We think the predictive power is pretty good. We send out the material as good focus group facilitators. We send the material out about a week beforehand so that the participants can read through it and understand it before they come together in the focus group, so that the focus group is just talking about the actual content. It's actually productive right from the very start. And we ran it over 2 sessions, discussing the model itself and data warehousing all on the same day. And it turned out they didn't like it. So yeah, we've spent a couple of months getting this model together. We're really excited. We think we're really onto something. We're going to put this thing out into industry, and it's going to really revolutionise the data warehousing industry. It's going to make it really successful. And the consultants come in and look and they go, no, that's not going to work. So close. This is what we actually ended up with as a result of that focus group session. What changed? Even though we're kind of disappointed they didn't like it, and this model that's come out is actually really quite ugly. I think it's not a very nice, neat methodology. It does highlight some concerns that industry had that, in reflection, they're absolutely right. The first thing they didn't like was the idea that you had initiation sitting out by itself. When you're talking about an evolutionary process, initiation is something that occurs and reoccurs each time you go through the evolutionary cycle. So they preferred to think about it in terms of initiating an evolutionary cycle, but also planning the project. So they said, look, it's really about strategy and resourcing, and that can break down into planning and initiation. So it's not just initiation by itself. The data warehouse data warehouse development side of things is really about the design process, they argued, and it's about looking at where the data is sitting, what data we're trying to bring in, designing the ETL process, and also designing the logical and physical data models for the data to reside in. And then there's a whole lot of stuff that happens with implementation that's actually really ongoing work. It's not implement the system, build the technology, and deploy it and sit back and watch it get used. There's a whole lot of effort in data warehousing that happens on a day-to-day basis as users are interacting with the data warehouse. Not only are you monitoring the usage, but you're continuously tweaking and refining and keeping the system going along. What we're going to look at in a couple of weeks' time is the idea that data warehousing is actually a chaotic process in the chaos theory sense of chaotic. That is, they're incredibly unpredictable systems. The life of a data warehouse manager is actually really hard. The damn thing just always breaks for some reason. No matter how well engineered the system is, it always seems to be breaking down. And the reason for that is because it's sitting in the middle of a complex interaction of a number of different systems. You've got all the source systems, you've got the ETL process, you've got the warehouse itself, and then you've got all the different delivery systems interacting with the data warehouse, and then lots of different users with different requirements all interacting. So you've got this complex interactive structure that exhibits chaotic tendencies. It's very difficult to predict that the system's going to be working tomorrow, no matter how well the system is engineered. So being a data warehouse manager is actually quite depressing. You start to question your abilities. And really it's got nothing to do with you or your team. It's just a fact of life, of running a chaotic kind of system. Things will go wrong. Things will break. So they argued that, look, this is not really development or implementation, it's really operation. It's an ongoing process of continuous refinement. And this process, the process is driven by this flow of information from source systems through the data warehouse to the delivery system. So really, this is about managing that flow of information, and it's an ongoing process. And then finally, there's the remnants of our original model. Use, delivery system development. They argued that you should tease those two things out as well, tease these out as processes, but these are actual pieces. This is an actual technical artifact, of course. So, and use then drives in an evolutionary way the design and strategy and resourcing as well. So you've got two sort of frequent functional evolution and high-level application evolution going on as well. So this is the final model that we ended up with, and we're not so happy with it. We think it's kind of complex to wrap your mind around. Lots of things going on. It's not very neat. Hasn't had much uptake by industry, but it does serve the purpose of saying, look, there's a number of different issues throughout a typical data warehousing project. And if you don't pay attention to the delivery system, if you don't recognise that running the data warehouse is a main source of the main part of the effort of doing data warehousing, then you're going to end up with a failed project. But they did recognise that usage is really key. If you don't monitor usage and keep track of usage and have a close relationship between the development team, data warehousing team, and the end users, you're going to miss changes in requirements, and the whole thing starts to come apart. Okay, any questions about any of that? Yep.
So in the middle of data warehouse design,
Yep.
does it include the delivery system also?
No, the delivery system is kind of, there's a bubble down the bottom right there that happens, and it's important that that happens in conjunction with the data warehouse design, but it is very often split into two separate projects. And that's not unreasonable to do. If you're sitting around waiting for the data warehouse while you're building the delivery system, chances are you're not going to get material out to the end users quickly. And that's one of the key determinants of success, is getting something quickly out to the end users, demonstrating that the system can deliver value, and that then encourages the organisation to invest in recurring funding for the whole thing. There's a lot of data warehousing or BI projects that have failed because the data warehouse has been the bottleneck. So developing the data warehouse has been the focus of the project. Delivery systems been left to wither on at the side, and then the whole thing just gets canned. I mentioned a failed data warehousing project that Steve Remington worked on, for those of you in Steve's tube, and I said you should ask him about it. That's a classic example of that. They got stuck working on the data warehouse, I think, for about 18 months before they built the delivery system. And they got to the point where they reckon they were about a month away from delivering some screens to the end users, but the organisation said, no, we're scrapping the project. Yeah, and it's something that David Arnott will talk about in 5094 quite a bit. Actually, the same case study, arguing that you've got to treat them relatively separately. Don't let the data warehouse hold up the delivery system. But the corollary of that, of course, is the data warehouse does provide the infrastructure, so don't let a lack of data hold you up as well. You've got to fix those data problems too. So a certain amount of separation, but cooperation is important. Yep.
Delivery system development, going back to delivery system?
Well, because it's an evolutionary process. You build a technical artifact, people use it. That limitations of the system drive pressures for change as well. So remember the Microsoft methodology where there were two feedback loops? One was the user experience and one was sort of technical requirements. So the user experience goes through use, and the technical requirements sort of go from delivery system development back to the delivery system. So it's that two-way interaction there. So, yeah, technical requirements here, usage kind of goes like that. I've lost my screen. Okay, so strategy and resourcing, I've talked about that. Some key issues with strategy and resourcing is making sure you get a business sponsor. If you don't have a business sponsor, a project champion, you're going to come up against organisational resistance. The fact that you're tinkering with information structures, information flow throughout an organisation, you're changing the way people access information. It means that you're changing the way people interact with each other from an information politics perspective. Again, this is something I'm going to talk about in a bit more detail in a couple of weeks' time. But when you start playing with how people access information, and you potentially undercut the organisational political power that some managers have. Now, if a manager controls information, then they have a certain amount of power in the organisation. This utopian view of let's provide everyone access to all the information in the organisation starts to challenge some of those power structures, some of those empires that get built within organisations, you will come up against political resistance. Not only from the managers and the users, but also from the IT department as well, the people who run the source systems. All of a sudden you're adding a regular drain on their processing power when you run the ETL process. So there's a certain load that goes with extracting data from source systems. There's also certain pressure from a data quality perspective to change the data in source systems. So if the data's incorrect or it's not in the right format for the data warehouse users, there's a pressure on the developers or the maintainers of the source systems to change their systems, and that means that money's got to come from a budget somewhere. There's got to be resources to actually implement those things, so developers and so on. So you can come up against resistance from the IT department as well. Getting access to the data can be quite hard. In the case study that I keep going back to Steve's failed data warehouse case study, one of the things they came up against was the fact that the organisation had outsourced their source systems to their main competitor. So big insurance company, two big insurance companies in the market in a particular state, and the insurance company that Steve was working with developing a data warehouse for had outsourced all of their IT to their competitor, and their competitor owned their data. So getting the data into the data warehouse meant a 6-month delay of negotiations, changes to contracts and things like that. Anyway, so getting a really senior, organisationally powerful project champion, project sponsor can help overcome a lot of those political issues. So there's an organisational mandate that comes with having a project sponsor. So that's got to happen during strategy and resourcing. You also have to manage expectations about the evolutionary development process. It's not a traditional waterfall model IT project. You have to explain why it's different and then how you're going to manage that difference. So, like I said, expect resistance, has to be managed, and a key strategy is breaking down those evolutionary cycles into treat each cycle as a more traditional kind of IT project, and then handle the complexity that way. So key questions that sort of come out of that research project that are questions both for practitioners as well as us as academics looking to do further research in this area is, well, how do we manage the evolutionary process? Sure, we can break it down, but how do we manage the sort of long-term benefits that can be lost when we've got this sort of cycle-by-cycle focus? It's relatively easy to manage the benefits from the sort of small-scale, linear, single-cycle project, but how do we make sure we get the long-term benefits from the overall project down the track? How do we measure return on investment? That's actually a really tricky thing to do. If it's an evolutionary project, we don't know necessarily what the benefits are going to be, let alone have the ability to predict a quantity of those benefits in terms of dollar terms. So a return on investment calculation, how much do we spend to get the system, how much do we get back in terms of money as a result, is really difficult to do. A lot of the benefits from a data warehouse are things like the ability to respond quicker to situations, like that manufacturing industry case study I just talked about, the ability to make better decisions. It's impossible to quantify those benefits at the outset of the project. It's difficult enough to do in hindsight after the benefits are starting to be realised, but almost impossible to do from the front. So how do we manage benefits and return on investment for these kinds of projects? How do we build the business case? What do we do about business data ownership? If you outsource your data, how do you get the data into your data warehouse? And what happens to organisational culture? If there's a culture in the organisation of sort of information protectionism, when you deploy a data warehouse, that directly challenges those kinds of power structures, and that becomes a real issue too. So often data warehousing projects fail not for any technical reason or because the system was poorly designed, but purely because the organisation wasn't willing to change its information culture. So that's a real challenge as well. So moving on to the development process, it's about defining the requirements and doing the conceptual and physical design and implementing the ETL. And that idea of chunking up the evolutionary cycles into single cycle phases and rolling out the project in a managed kind of way. There's some key issues here, particularly for managers from a sourcing perspective. If you've outsourced a lot of your operational systems, then that becomes a real challenge. But also, even if you do own the source systems yourself, simply working out what data's in those systems, doing the corporate data modelling stuff, is a real challenge. It can be very expensive, very time consuming, and that happens before you even start to get any of the data out to the end users and get those quick wins. So that can be a real problem. And there's some real technical problems with data duplication. In fact, there's organisations, there's vendors who specialise in products just to do what's called deduping. In other words, identifying duplicate records in source systems and deduplication, working out that these two customers are in fact the same person, or these two people with the same name are in fact two separate people. Yep, so gathering requirements is really tricky. Really the best way to gather requirements is to build the system, get it out to people and start getting them to use the system, and that drives the requirements. So it's really important to actually focus on the decision-making side of things rather than the data management technical side of things. Certainly data management, data sourcing is probably the key technical challenge for a data warehousing project, and you have to get it right. But the focus should be on improving this. As soon as you lose sight of this and focus more on the sourcing, then you're going to potentially derail the data warehousing project. You can get really bogged down in the sourcing side of things. Implementation, getting the tools right is important, but not in the way that you may think that seems intuitive. The tools are fairly standard, so a lot of organisations will use the same relational database management system, for example, that they use for their transaction processing systems. So if an organisation's got an Oracle database management system for their point of sale system, chances are they'll probably use Oracle as their data warehouse platform as well. So it's not so much that choosing the wrong technology means that you can't develop the appropriate technical solution. They all interact with each other, they're all mostly standards compliant. It doesn't matter whether you choose Business Objects or Cognos as a delivery system, they'll talk to an Oracle or a DB2 or a Teradata data warehouse, and they'll talk to various source systems as well. The key thing really is the talent and skills that you've got in terms of the human resources in the organisation. So if you've got a team of people who really understand Oracle really well, then you really should choose Oracle as the data warehouse platform. If they really understand DB2, choose DB2. The reason for that is because the usage of the data warehouse is unpredictable, because it's kind of a chaotic system, you need people who understand the nuts and bolts of the technology, exactly what tweaks to make and the impact that those tweaks will have on the configuration of, for example, the database management system to keep things ticking along nicely. So getting the tools right is important, but it's more driven by what skill set you've got in the organisation already, rather than choosing the wrong technology because it won't interact with another component in the BI stack. Does that make sense? Okay. You need to think about how frequently you run the ETL process overnight, etc. That real-time stuff, I'm very sceptical about it. Getting the physical database design is important. And here we're talking about lots of denormalisation, getting away from the mindset that a lot of data models have of it must be third normal form. It doesn't have to be. And there's very strong reasons why it shouldn't be. There are counter-arguments to all of those though, so hence the ongoing debates between the Imanites and the Kimbalites. Yeah. You also have to think carefully about building a data warehouse means you're shunting a lot of data around, so it's not the data warehouse as an artefact that's a problem. It's the fact that there's a process of moving information from source systems to end users, and we're talking often terabytes worth of data. So you need to make sure that you've got the infrastructure to support that kind of transport of information. The networks are capable of moving that data around quickly enough, etc. So, key questions for particularly us as academics is, what's the best way to go out and gather requirements? Obviously, usage is a key driver of those requirements, but what's the best way to monitor usage, to interact with the users, form that relationship with the users that we can recommend to industry? And obviously, that's a problem too on the ground. So if you're a practitioner, how do you actually implement that in the organisation you're working in? Granularity is something we'll talk about next week, but it has to do with the level of detail in the data warehouse. The more detail you've got, the closer you get to the original transactional data in the data warehouse, the more flexible that data is, but obviously the larger the volume is as well. If you summarise the transaction data, if you chunk it up into, for example, sales per day rather than individual transactions, then you can save a lot of space, you can fit a lot more data into the data warehouse, but the chances are you may then not provide adequate decision support because you can't then backtrack to the individual transaction. So getting that level of granularity, the level of detail in the warehouse right is quite key. As I said, we'll look at it next week. Outsourcing is a key issue. Generally recommended not to, but we have seen some projects where it has worked. And finally, operation it's all about that process of moving information to the right place, to the right people, at the right time. It's that classic kind of statement. And things just go wrong. So taking this kind of publishing mindset, though, is quite useful. So publishing is about, I described earlier, as a process of refining data, packaging it up. In publishing it's packaging it up usually in the format of a book, editing that to make sure it's of an appropriate quality, looking for spelling errors and things like that. With a data warehouse, the same kind of thing happens, and it's all about managing risk. We know things are going to go wrong, we know the ETL process is going to break from time to time, and having someone there thinking of data warehousing in terms of a publishing process, putting in that sort of sanity check before the data gets published to the end users, means that you can capture some of those errors before those errors cause a problem. So it's about managing risk. Other key issues alongside of that sort of risk management of operations is how does the data warehouse and the data warehouse team interact with the rest of the organisation? So what are the sort of the governance issues with data warehousing? That's something we'll talk about right at the end of the semester. But there are real challenges. Who pays for fixing up data quality? Is it the source systems, where the source of the data quality is first introduced? Or is it the data warehouse team who have to pay for it? Who gets to decide which direction the system evolves in? So if you've got multiple groups of users, each with their own sort of set of requirements, whose requirements get prioritised first? Whose requirements get satisfied? Is it the CIO or CFO requirements because they're a C-level executive? Or maybe there's more important business requirements that need to be supported first. So governing these kinds of things becomes a real challenge. It becomes a process of negotiation. Getting data quality right is important. Training users is important, but that's more 5093 kind of material, the front-end delivery system issue. But what we're aiming for is intuitive, easy to understand, self-reliant, systems that create self-reliant users so that users can sit down and explore the information, use the system in ways which we can't anticipate, as much themselves as possible. If they're relying on us to train them, and if they don't understand the system intuitively enough to do anything beyond what we simply train them in, then evolution is going to be stilted and requirements will not be met. So, key problems for us from an operation perspective. How do we define data quality? We're going to have a lecture on that as well. It's not as simple as simply saying, is the data correct or not? There's actually a lot more complexity involved. And also, how does the system operate in terms of relationship to the legacy, the source systems? And what impact does that have on the source systems as well? Okay, what we're trying to do with the delivery system, of course, is keep our end users happy, keep them informed, give them a system that they want to use to solve their business problems, and which encourages exploration and learning and ultimately informed decision making. And monitoring usage is a key thing there. So lots of different ways of doing that, but the focus should be on making sure that decision making in the organisation is higher quality and more effective. So really, if we're doing data warehousing or business intelligence without a really good understanding of what decision making is, then chances are we're not going to provide proper decision support. We're not achieving the objectives of the organisation. The number of IT people who are trained in decision making is close to zero. For those of you doing FOVO 94, you'll learn about decision making. This is why we teach you about decision making, cognitive psychology and things like that. But if you don't understand that process, then how can you possibly design an IT system to support that process and improve it? So it's really key to maintain that focus on decision making style and effectiveness, and recognising that different people have different decision making styles. So this kind of idea of one size fits all just doesn't happen in organisations. That being said, particularly in the 1990s, that was the prevailing mindset. And one of the reasons those MIS systems in the 1960s failed too was that one size fits all. Let's build a system, put all the data in there, and then everyone can make better decisions. It just doesn't happen that way. Okay, usage, I'm going to skip over that. key questions for us. How do we measure effectiveness of the warehouse? How do we measure benefits? Calculate those return on investment things and so on. So we've got a few different case studies, 3 different research projects trying to answer some of those research questions. We're doing survey work that looks at what's happening in industry, particularly here in Australia, to see if there's any differences with what gets reported in the US literature. The data warehousing literature, both vendor literature and academic literature, is predominated by US case studies, US organisations. There's very little in the way of case studies from Europe or Australia or Southeast Asia or China, and that tends to skew the lessons that come out. So the technology tends to be designed for classic American Western style corporations, usually large Western American corporations. So applying data warehousing in small to medium sized organisations, applying data warehousing technology in organisations that have a very different culture to American style corporations can be a real challenge, because the technology is designed with that particular culture in mind. So we've done a bit of work looking at cross-cultural comparisons of development here in Australia, which tends to be very American style, and we've had a few Thai students, so we've done a couple of case studies in Thai companies, and there really is a major difference in terms of organisational culture that had an impact on those BI projects. So we're doing work on that. We've got a PhD student at the moment looking at the issue of BI benefits management and return on investment. Just about to publish his PhD. He's this close. And BI governance is something that I've been working on, David Arnott's been working on as well. So that brings us to the end of the lecture, which could be fairly well summarised with this dot point. Data warehousing is an evolutionary process, and it has to be managed. So that's the lesson for week 2. Any questions from you guys? No? Some of you may have looked at the tutorial sheet on the tutorial page on Moodle and noticed things were a little bit broken. They've been fixed as of this morning. Importing the site from last year's version to this year's version, the links got broken, so I didn't pick up on that. So it should be all set to go. Just before you leave, just to word you up on the tutorial, the point of this week's tutorial is to lay the groundwork for next week's material when we look at dimensional modelling. So it's going to be a bit of SQL, and we're going to give you a classic third normal form model and a star schema, multi-dimensional model, and compare the kind of SQL that you need to do some basic reporting.
So the dimensional modeling includes MDX, not SQL?
No. Mostly uses SQL. Yeah. Good. Excellent. A less facetious answer is yes, MDX is for multi-dimensional stuff, but SQL can be used as well.
You can have a look at the SAS software.
Well, I'm not sure because I don't use it. I'm not sure what the process is.
Okay. I'll send you the links and whatever.
Yeah, if it's just an email or something like that, then yeah. Cool. Thanks. Cheers. You mean the methodologies? The Microsoft one is in their second data warehousing textbook, so it was published in 2002, and something obvious like Microsoft data warehousing, something like that. Craig, Vivona, and Berkovich are the authors. So if you do an Amazon search for Microsoft data warehousing, you'll find it. I mean, Monash EA is well, that's the Monash BI method. What we did here was the Monash data warehouse. So it's similar, but specifically focused on the data warehouse rather than the delivery system. Howdy. Good to see you again.
Yeah, thank you. Good to see you too. You were talking about the moving of the tutorial, and it's 4 p.m. you said. Is it this one?
No, it was the one that was on Tuesday at 10 o'clock. So there was a tutorial at 10 o'clock Tuesday,
Okay.
and that's moved to 4 p.m.
Okay, so this is not affecting.
So that one's still there. Yeah.
Okay. Cheers.
Tomorrow's lecture will move to 4 o'clock.
Tutorial.
Okay, 10 o'clock tutorial.
The 10 o'clock tutorial, the one that I took last week,
Yeah.
is now today at 4 o'clock.
Okay, thank you.
If you're enrolled in that tutorial, you should have got an email. So check your Monash email. Okay. See ya.
It's more related than. Second, I will